Welcome to Basic Physical Chemistry. My name is Jonathan Agger, and for the next 2 weeks I'm going to be teaching you thermodynamics. The science of thermodynamics was born of the Industrial Revolution in the late 1700s and early 1800s. You have to imagine that up to that point, all heavy-duty work was performed by horses. Indeed, to this day, we still use horsepower as a measure of the rate at which work is performed. The Industrial Revolution was all about the development and exploitation of a fantastic new invention, the heat engine. Heat engines use fuel to heat a working substance, usually a liquid or a gas, to high temperature. The working substance then generates mechanical work in the body of the engine while transferring heat to a cold sink. Thermodynamics was developed to gain the maximum efficiency from such heat engines, and the science was so successful that in a very short space of time, steam engines completely transformed the world, from transportation to manufacturing to agriculture. Out of the science of thermodynamics arose 4 fundamental laws that govern the interrelation and interconversion of heat energy and mechanical energy. We are going to study those 4 laws in detail, and in doing so, we're going to learn about concepts such as temperature, internal energy, enthalpy, entropy, and Gibbs energy. Despite thermodynamics clearly being of immense practical importance, it is often perceived by undergraduates as quite abstract, with concepts that are difficult to grasp. My aim in these lectures is to clearly explain such concepts and hopefully give you a feel for the useful nature of this highly important science. Modern-day heat engines, such as the one found in the world's fastest production car, the Bugatti Veyron, are testament to the progress we have made since the early days of the steam engine. In 1829, Stephenson's famous rocket set the world land speed record at 35 miles an hour. Today, the Veyron produces 883 kilowatts, or 1,184 brake horsepower, and has a top speed of 268 miles per hour. With regard to the structure of the course, there are a series of video lectures to watch each week, ranging from around 5 to 15 minutes in length. There is a formative 10-question multiple-choice test to complete each week in order to gain feedback on your progress. At the end of the course, there is an assessed 10-question multiple-choice test. There is also a virtual practical for you to try, in which you will use a chemical reaction to calibrate a calorimeter, and then use the calorimeter to determine the heat released in a second chemical reaction. The practical will also be assessed. If you have questions, then feel free to discuss them on the forum. Teaching assistants will be there to help you, and I shall visit the forums regularly. It just remains for me to wish you good luck with the course, and I hope you enjoy it.